Hello Loite, my name is Dhruv Sharma. Welcome everyone on our session on F5 iCall. So in this session, we're going to discuss about what is F5 iCall and how we can use it within our infrastructure. So with this, we will start with introduction. So F5 iCall is basically an event-based management system. So it's not just the first time F5 came up with the I future concept. We already have a concept of I rules, which is data plane programmability, I control, I apps, I call, and TMSH. So in this session, we will be purely concentrating on I calls. I calls, as I stated earlier, it's an event-based management system. It doesn't, it is not an API related function, but it's an event-based management system, and which we will look into or in the detail in just coming up slides. So the building blocks of iCall three is basically three pillars. The first pillar is the event. Event is the message that that happens that happens within the F5 that ask F5 to perform certain actions. So, for example, there is a virtual server goes down, a pool member goes down, and we want F5 to perform certain action when a specific event happens on the F5. So the event section identifies the event that happens, a message that triggers within the F5, and the script identifies what action or the what action is performed, what we would like to perform when certain event happen on the F5. So this is the action and this is the event. To and the handler plays a very vital role where it bridges the gap between the event and the script. So when the event happens, the handler ensures that a specific script is executed. We'll move on. So this is the basic flow. When there is an event, handlers ensures that the script is executed. Very simple, nice and easy. But it can get very complex when a handler forwards the event to a script, and the script forwards the event it to another event, and then finally a handler forwards it to a script. So it can get into a nested environment as well. We'll go into much deeper about these three building blocks of iCalls. So the first was the event, as we discussed. It's an event, is a message, it's an act, is an occurrence of a certain activity where we would like to monitor. You know, in a routine IT infrastructure, it happens when there is a virtual server or an activity goes down, and in the meantime, the operation guys try to log on the F5 to capture the event. The issue is it could not be seen, or it's automatically gone. So one now recently we had an issue where the F5 goes down, and by the time the L3 engineers used to log in on the F5, the issue was gone. So to come across such activities or such scenarios, iCalls plays a very vital role. So events, as I mentioned, can be an any event, a pool or a daemon or an I rule as well. So all the events are placed within this location, user config user underscore alert.conf. Second comes a handler. The first is a triggered handler. So triggered handler basically means that certain uh, event happened, and we will use the triggered handler when there is certain event happened, like in as I mentioned, the F5 pool member goes down, that triggered the handler to be active, and then the handler will ensure certain actions are performed. So that's a triggered handler. Periodic handlers, they don't need any, I would say, an event, because these are the periodic activities. A very usual use case is an example that we can configure our F5 iCalls to download the CRL from our CRL servers on a periodic basis. So that's a very good use case for a periodic handlers. And third, the perpetual handlers are basically used for the daemon purposes. So if there are specific daemons within the F5, we will be using the perpetual handlers. And finally, the script, which is the most important part, which ensures that the certain actions are performed that are instructed by the handlers. We'll see them detailed during our live session as well. So these are the commands what you guys can use when you will write what you will write the scripts. By the way, this iCall feature was introduced from 11.3 version on the F5s. So in the use case, we will be using this topology in a lab where a user who will be trying to access a F5 virtual server, which has an IP address of 10.10.10.110, and that connects to a pool member 192.168.18.128. So this is the configuration, very simple. That's the alert setup. So alert setup is basically, as I mentioned, this is the location where we're going to create an alert. So that's the script what I have used, which shows that the pool member PHP I have a pool and I have a member called PHP within my lab, and that has an IP address 192.168.18.128 as mentioned in this topology, and that has a pool state. And if the monitor status goes down, execute a unique command to take a TCP dump. So what I'm saying that if my pool member PHP member, which I will show you in just 2 minutes, if this goes down, then start taking TCP dump with this matrix. So because when the pool member goes down because of any reason, because of health monitor failure, I don't need to wait for someone to come back on and log in on the F5 to take the captures. So this removes lots of overhead from my operations team. So just a tip: anytime you make changes on the services, ensure that you perform a TCP restart. So it's a TMSH restart alert D. So this is the daemon which basically ensures that this service is running. So now we will configure the script. So we go under the root and under the tmos, and we use this script. I will maximize it for you all. Create sys iCall script pools down script, and then we give a name, edit script pool script down, and in the script I will identify that once the script goes down, you have to execute this command, and I given the name dhruv.pcap, and this is the VLAN name. Nice and easy. So finally, the handlers. So the handlers are basically bridges the gap between the between the script and the event. So what we are basically doing in this scenario is we are informing we are creating an event that as soon as a pool member goes down on our F5, run a script that captures all the traffic on the certain VLAN. So that's the prime objective of this testing. So this event can happen anytime. Obviously, in our lab environment, I will be manually switching down our pool member to make the pool member goes down just for the demonstration purposes. But yes, in your live environment, you can use it for any troubleshooting purpose. So we create a handler, we call the script what we created earlier, we call the event unique TCP dump what we described earlier, we give the name of the event as unique TCP dump highlighted in this pink color, and we define the action that needs to be performed. So that's a very plain and simple stuff. We create the script, and as you can see from the script, we have defined that to perform to take the TCP dump. It's a very Linux based command. So it's very simple stuff to know. Similarly, we create a handler. Finally, once we are done with creating the script which defines what action needs to be performed, we define the TCP dump, that's the action needs to be performed, and the handler which connects the script and the event. Finally, uh, the last piece which is very important is to know what the troubleshooting steps which we need to perform when we are stuck up in some issues. So this is a very good commands which we can use, like show sys iCall that shows the events, that shows event matching the filters. And so in my case, I've created a event pull down. So, and as soon as there is an event, the number will increase. So you can basically see the current status is down and all sort of good stuff. And in my action, if you see the script, you can see that in my action, it shows that a capture is created dhruv.pcap in var.temp file. So over here, if we see, if we go under the var.pcap stuff, we can basically see a dhruv pcap should be there as soon as the event is triggered. So having with this, these are the references material which you guys can use. I will be leaving these reference material within our repository section on our link. So let's get down with the practical stuffs. If we if we log on our F5 devices, okay, let me take you to the virtual server. It's a virtual server, and that's the IP address 10.10.10.111. Very basic F5 virtual server, nothing fancy about it. And the resources, the pool member is PHP. That's a PHP virtual server, and it has the very simple HTTP monitor, nothing fancy, very basic. And that has a pool member. It's a web server that has an IP address 192.168.18.128, and I given them as Lampio. If you go back to the configuration, if you just compare what we have written I think it will all match it to what we have created. A pool member PHP. So if you go over here, that's the pool name PHP and the Lampio and the IP address. Lampio and the IP address, which I've mentioned it based on the name. I can customize this script and I can create a very complex and based on your requirement. So it's basically TCL language what we are using. So how good you are with the TCL language, more complex iCall script you can create out of it. Okay, so if I just do a monitoring, that's the virtual server IP address, that is 10.10.10.11. I've already opened it on my browser. It opens. It should be opening now. Yeah, it's opening up. Okay, it opens up perfectly fine as we have expected. And I think what we can do right now, let me show you some configurations from the CLI. Show this iCall. So these are the old events what we have there, what we have already been using it in our environment, in a test environment. Currently it shows that the event we have handlers handler name is pull down, and we have following 6 events which are matching the handler. let's look into some of the configuration. So if I go into edit sys iCall handler periodic, so sorry, I think it should be triggered pull down. So it opens up in within a VI editor. So it's a quite a common editor what we use within the Linux environment, which shows that this is the handler which use the script pull down script, and this script basically performs this action which has a unique event name, unique TCP dump. So this handler connects two stuff. One is the script and other is the event name. I hope it should be clear by now. So handler connects the script and the event name. I will WQ and I will come out from here. No, I will not like to save the changes. Let's quickly look into the iCall script pull down script. So just a quick reference, this name remains the same and I have identified the action that needs to be performed. You can place in any action. So you can ask F5 to download the CRL from a website. You can ask F5 to do any sort of action, obviously within its capability. You can't ask F5 to give a call to your girlfriend, obviously. Okay. No, I don't like to save changes. Finally, I will take you I will quit, and I will take you to the section where we have stored the script. So it should be under D. It should be under the config. So if I do a cat user alert and config, you can basically see that's the script what we're talking about, which is already shared within the document as well, which shows this is the pool member PHP and this is the member IP address, and this is the alert name which shows monitor status down. So now what should happen if I switch this down, the pool member Lampio, where is it? Yeah, I go back to the pool member. If I switch this pool member down manually, so as per the script, because script is the one which performs the action, it should start taking the TCP dump. So where is the script? Yeah, here is the script. The script performs the action. Event is the event when certain events happen. So that's an alert which shows the monitor status goes down, and the event is the event happen, and the script is the action that needs to be performed, and the handler connects the event and the script. Nice and easy. Now we will give you the quick demonstration. I will go back on the Lampio and I will switch this down. I will wait for the F5 to bring this pool number down. We'll wait for a couple of seconds. It's still showing up. Okay, let me refresh. Yeah, it's down. Okay. So if I go back on, as I shown you previously, the even matching the filter was 6. If I go back on my PMSH, show iCall, 1 second, let me bring up the logger. Let's wait. Okay, message, show sys iCall. Status is 6. this is a logger command that ensures this command. Let me give a one more try, please. Uh, Hi guys. So we were discussing that once the pool member goes down, basically it should show sys call. See, the number of events has increased. So this is this as we can see, the number of events increased from 6 to 7 as soon as we switch down our pool member. So we can look it out once again. So I will switch this pool member up. If I go back on the temp directory, so see, it created a capture dhruv.pcap and by today's date. So it created a pcap. So I will remove it again to give everyone how this can work, and we will set the logging for troubleshooting purpose, and and we will and we can see we will try to bring this pool number down. Let's confirm if our pool number is up now. We'll give a one more shot. Yeah, pool member is up. Shows this icon. So we're going to give another shot now. The number of events matching the filter is 7. We'll bring the pool member down now. Okay. It's down. So it should be reflected back on the website. Let's wait. It should come up. I will put down the logging if in case something doesn't work. So it's a VM, so it sometimes create a problem. Let's wait. Yeah, it's indeed down. Let's quickly go back and see what's the status. Yes, see, the event has increased from 7 to 8. Let's quickly go back to the temp directory and confirm what's the status. NSL, I will grep for the name. Yes, we can see the packet capture, which is again captured from this size. So that demonstrates how this stuff work. It's very easy. So, but yes, it's an art to create how complex files you can create, and that's all about iCall. So I hope this session was useful, and thanks everyone for joining.